afternoon, everyone, from IIT Gandhinagar to this fifth, I think, edition of our series on Indian scientists. Our intention, this was the brainchild of my colleague, Professor Sudipto Sarkar mainly, and I've been assisting him in this, was really to highlight a number of Indian scientists from the 20th century, mainly speaking, sometimes going a little bit into the late 19th or a little bit into the early 21st. And of as many disciplines as possible, we felt that these Indian scientists sometimes did not get their due recognition or sometimes fell into some kind of oblivion. And it is the ambition of this series to bring them back to light and also acquaint the broader public with a number of names that it might never have heard. So among the scientists we have covered so far are Satyendranath Bose, the physicist, Meghnad Saha, G.N. Ramachandran, Prafulla Chandra Roy. In fact, there were two talks on him. Harish Chandra, C.V. Raman, Obey Siddiqui, Salim Ali, and the last was A.K. Roy Chaudhary. We hope to continue for as many semesters as possible. We have one such event per semester. Hopefully the next semester we would conduct it offline in person, hopefully. And this is therefore a kind of accumulating list of scientists that perhaps one day we can do something more consistent with. We are very happy today that we have two scholars who are going to tell us about two pretty little known figures from physics and from chemistry biology. So I request Sudipto to kindly introduce our first speaker.
Thank you, Michelle. So the first speaker today is Professor Srubabati Goswami, and she's going to talk about Dr. Bibha Chowdhuri, a star from another sky. Professor Srubabati Goswami is currently a senior professor at Physical Research Laboratory in Ahmedabad, PRL. And Professor Goswami herself is a very distinguished and leading high-energy physicist in India. She is very well known for her pioneering work on neutrino physics and other aspects of high-energy physics. She is also a member of all the three Indian Science Academy. We are very happy and very grateful that she has accepted this invitation and agreed to give this talk. So Srubabati, it's up to you.
Thank you very much, Sudipto, for those kind words of introduction. And it's really heartening that you are organizing this series like, History of Science and then the Indian seminar series on Indian scientists. And it is really a privilege and an honor for me to talk about Dr. Bibha Chowdhuri, who actually happens to be my predecessor in PRL. And it's a double honor that I am able to talk about her and bring her and to work to the notice of the others. And so I will start with this. And this is a picture of HD 86081. This is a yellow white dwarf star, which is in the constellation Sextans. And in 2019, the International Astronomical Union held a contest as a part of its centenary celebration and assigned India to name this star and its planet. And this was called the Name Exoworld campaign. And this star, some names came, and among which I think the Indian counterpart chose these names, and this star was named Bibha, and this star has an exoplanet, and which it was named Santa Massa, which means clouded. And these names were suggested by some students from India. So, but it's very symbolic that, this was it is like a clouded star. And as I unfold my seminar, and then you will see that why this is such an apt description for this planetary system also, this for life of Bibha Chowdhury. So I start with the early life and family of Bibha Chowdhury. She was born in Calcutta in 1913. Her father was a doctor and mother belonged to the Brahmo Samaj. Now, Brahmo Samaj in Calcutta at that time was, it was going beyond the conservatism of the Hindu religion, and it led a lot of Renaissance movements in Bengal, and so it is not surprising that all the brothers and sisters of Bibha Chowdhury were very well educated. They also remained unmarried, and so that is a part of a problem that very little information is available about her. So she studied in Bethune Collegiate School and Herambho Chandra College, and then she did MSc Physics in 1936 from Rajabazar Science College. I also studied there, and she was the only woman in her class. And what I read is that she was not the first woman to study physics from Rajabazar Science College. I think there were two other women before her, but it is not very well known that what they did later. But at least Bibha Chowdhury continued in research, and later during her PhD in Manchester, she was asked in an interview that why she chose physics, and she said, "I just followed my inclinations." So after finishing her MSc, she wanted to do research, and she started research with Professor D.M. Bose. Professor D.M. Bose was in Science College, and Professor D.M. Bose was the nephew of J.C. Bose, and then after J.C. Bose, she became the director of Bose Institute, and Bibha Chowdhury shifted there. And they worked on the topic of cosmic rays. So this is an old picture of Bose Institute, and this is Professor D.M. Bose. So before I come to Bibha Chowdhury's work, I think it will be relevant to talk a little bit about Professor D.M. Bose and the cosmic ray research, worldwide cosmic ray research at that time, to put things into perspective. So Professor D.M. Bose did post-graduation from Christ College, Cambridge, and he was taught by stalwarts like J.J. Thomson, who discovered electron, and Wilson, who discovered cloud chamber. He joined physics department of Calcutta University in 1914, and he was provided with Sir Rashbihari Ghosh professorship, which provided him a grant for research abroad. So with this grant, he joined the lab of Professor Erich Wegener in Berlin. And Erich Wegener at that time was working on cosmic rays, and D.M. Bose worked on a new type of Wilson cloud chamber and detected the tracks of recoil protons during passage of alpha particles in hydrogen filled chamber. I will discuss later that this was a very, relevant step in the subsequent development of the field. He got his PhD in 1918, although he joined the lab of Professor Wegener. The name of the guides were written as Professor Rubin and Max Planck, and these informations I found from this book, D.M. Bose, His Life, Science and Connection with Global Elites by S.C. Roy and R. Singh. And actually what these authors claim, and what I also feel, that, Professor D.M. Bose also did a lot of path-breaking work, but maybe we did not know about him that much. And mention about his cosmic ray research, because Professor Wegener's lab was famous for cosmic ray research. It was D.M. Bose was already aware of cosmic ray research, and there were some research transcripts of Bose Institute during 1935-36 where mention of his cosmic ray research can be found. So what are cosmic rays? Cosmic rays are high energy charged particles, basically protons and atomic nucleus, and they produce electromagnetic showers consisting of charged particles and photons entering the Earth's atmosphere. So these cosmic rays hit the air molecules in the atmosphere, and they produce a lot of particles. And they were discovered by Victor Hayes in 1912. And what led to this discovery? This discovery came from the puzzle that there was an unknown radiation which created some signals in the electroscope. So electroscopes are devices which measure, which can detect the charge of the of any charge body. And what happens is that the radiations can ionize the air in the electroscope and allow the charge to leave away. So if there is a charge, then these leaves will be deflected, but there will be if the radiation ionize the air, then the charge can leak away and the leaves will come together. So what scientists found was that electric charge continued to leak away even without any source of radiation. So there were a lot of, first people thought that it is coming from the rock of the earth, and to prove that it, people went up went at height like on Eiffel Tower and to measure the radiation, but the puzzle was not solved. And in 1912, Victor Hayes undertook 7 balloon flights carrying simple electroscopes. He climbed up to 5200 meter and they found that the ionization increases with altitude. So this was not a very, it had a lot of risks and to climb up, and he took 7 such flights, and he did measurements in both day and night and found the same effect. So this established that it is extraterrestrial in origin, and because it is coming from both day and night, it is not from the sun. So for this discovery, he got Nobel Prize in 1936. And so this was called Venstrahlung, or high altitude radiation. And after Hayes, Kohlhauster also did this measurement, and this shows that this radiation increases with the altitude. And this is a different electroscope, which has more sensitivity than the ordinary gold leaf electroscope. So when I come to cosmic ray research and also Bibha Chowdhury's research, then it may be relevant to talk a little bit about cloud chamber, which was discovered by Wilson in 1911, for which he got Nobel Prize in 1927. So what happens is there is a chamber, and when ionizing radiation passes through supersaturated vapor, so there will be water or alcohol, and that will produce some vapor, and that will serve as the condensation. And as a result, when the small droplets of liquid can be observed along the path of radiation, forming the track. So another instrument which was useful for the research of cosmic ray 29. So there is a gas-filled metal tube which is connected to an electroscope, and particles penetrating the metal tube will produce ionization, and the current produces a deflection in the electroscope. So these instruments were very useful in further development of cosmic ray research. So Victor Hayes named it the high altitude radiation, but the term cosmic ray was coined by Millikan, who made the measurements of ionization due to cosmic rays. And he said that primary cosmic rays were gamma rays, that is energetic photons. In 1927, a Russian scientist, D. Skobelizin, discovered tracks made by cosmic ray particles in cloud chamber, which I showed. And then in 1929, Bothe and Kohlhauster introduced a new method for the study of cosmic rays by passing them through Geiger counters, and they found simultaneous discharge, which demonstrated that there are penetrating charged particles in the cosmic rays. So this was the cosmic ray found in the cloud chamber, and this is the device of Bothe and Kohlhauster, two Geiger counters in coincidence, and they found coincident signals. So cosmic rays proved to be a laboratory for fundamental particles. In 1932, Anderson discovered positron, the antiparticle of electron, from the tracks left by cosmic ray particles in cloud chamber. So they will bend in a, so this is the positron. From the bending, they discovered that this is a particle which has the same mass but opposite charge of the as the electron. And in 1936, Anderson and Neddermeyer discovered another particle with same charge as electron but a higher mass, and they called it mesotron. And later these particles came to be known as muons, and this was the cosmic cloud chamber developed by Anderson. Initially, the muons were thought to be Yukawa mesons, which were proposed by Yukawa to explain how the new protons and neutrons are bound inside the nucleus, and they were thought as the mediators of strong nuclear interaction. So initially, it was thought that this was initially thought that this is the meson. The muon was as the meson. Now, in this backdrop, in 1925, means during this time, Marietta Blau and Hertha Wembecker, her student, demonstrated the use of photographic plates as detectors to record tracks of charged particles. So we talked about gold leaf electroscopes, and then we talked about cloud chambers, which were giving tracks, and then we talked about Geiger counters, and then they developed the use of photographic plates as detectors to record tracks of charged particles. And actually they wrote that this was based on the scintillation and ionization effect of hydrogen shown by Bose and Macaulay. And so from that they got this idea. So that was acknowledged in the paper. Now, Blau vastly improved the nuclear emulsion films, experimenting with various chemical formulae, types of film and development processes, and worked with photographic manufacturers such as Agfa and Ilford to determine the best techniques to capture a variety of particles. And in 1932, Blau and Wembecker placed specially designed emulsion plates about 7,500 feet above the sea level on a mountain near Innsbruck, Austria. This was the Heffelecker Observatory of Victor Hess. And when the plates were recovered and developed, they found plenty of cosmic ray tracks, mostly protons. So they first found the evidence of cosmic ray tracks in photographic plates. And in 1937, they found star-like events, which they called disintegration star. So you can see that this is the plate, and like this is the kind of star-like events they observed, which is the evidence of disintegration of heavy nuclei by cosmic ray protons. So the photographic plate method was also studied in India. In 1935, H.J. Taylor from Wilson College, Bombay, studied alpha particles using special photographic emulsion manufactured by Ilford Company. Taylor and Davolkar studied cosmic rays with samarium-coated photographic plates and found evidence of tracks which were attributed to nuclear disintegration by cosmic rays. This paper was published in Proceedings of Physical Society of London in 1936. They published another paper in Nature titled Disintegration Process by Cosmic Rays in Plates Impregnated with Samarium. Then in 1939, a science congress was held in Calcutta in which Taylor and Walter Bothe mentioned about photographic plate technique. So with all this, Bose and Chowdhury embarked on detection of mesotrons using photographic plates and cosmic rays. They took the photographic plates to high altitudes in Himalayas, choosing 3 stations: Mayapuri Research Station, Sandakphu, and Farijong. And so what they will do is these plates were carried to these stations and they were exposed to cosmic rays, and then they will be brought back and analyzed. And they published 4 papers in Nature. So these are the titles of the papers: Photographic Plates as Detectors of Mesotron Showers, Origin and Nature of Heavy Ionization Particles Detected on Photographic Plates Exposed to Cosmic Rays, A Photographic Method of Estimating the Mass of Mesotron. There were 2 papers with the same title. So during 1940 to 1942, 4 papers were published in Nature. And now the question is whether they discovered pion or not. So this is a picture of, the kind of tracks they observed. And so they found this was half-tone plates. Half-tone plate means the emulsion film was on one side and they kept exposed to cosmic rays. And they said that these are, as you saw the title of the papers, they said they were due to mesotrons. And they made a comparison of the mean grain spacing and the curvature of track. So if you have the track curvature will be different depending on the mass, and so from that they estimated the mass. And in the 1941 Nature paper, the mean mass of the mesotron was found 81.9 plus minus 21.3 MeV. In 1942, they recalculated, and these values were 110, 171.7, 159.9. And the pion mass was 139 by 9.6 MeV. And in these papers, they never said that, they found pion or they found a different particle than muon. So they said it is the mesotron. Like at that time, the muon was called the mesotron. And so they said they found the mesotron. So the thing is that it seems that to me that they have seen some new tracks, but experimental resolution to distinguish pions was missing. And the cosmic ray research of Bose and Chowdhury stopped because, as per the annual report of Bose Institute, difficulty is being made in obtaining photographic plates from England. So this needed, further improved photographic plates, and that was not available. So meanwhile, in Bristol, C.F. Powell's group was also working on observation of cosmic rays in photographic plates since 1938. They greatly improved the nuclear emulsion method. And in 1947, he discovered actually two different mesons, and he found that, and so then this is the pion, and then it decays to muon. So he found discovered Yukawa's meson and found that it decays to muons, and the existence of two mesons of different masses were shown. Powell got Nobel Prize for his development of the photographic method of studying nuclear processes and his discoveries regarding mesons made with this method. Blau and Wembecker was also nominated by Schrödinger, but they did not get it. And that is very unfortunate, because that the cosmic ray can be observed in photographic plates was first shown by Blau and Wembecker. And there are a lot of studies, a lot of articles on whether there was, it was fair on Blau and Wembecker. And if you read Blau's, history, science, life and her science, it's like remarkable, the kind of persecution she faced, and not only as a woman, but also racial persecution because she was a Jew, and the kind of, research that she did, that is really remarkable. And Bose and Chowdhury was not nominated. And I think that's a missed opportunity for India, but in their research, they never mentioned that, it was a pion, and that they could not conclude. So the question is whether Powell was aware of Bose and Chowdhury's work. Powell did not mention about Blau and Wembecker or Bose and Chowdhury's results in his Nobel lecture. But in 1941, Bose, later in a book published in 1959, he wrote that in 1941, Bose and Chowdhury had pointed it out that it is possible in principle to distinguish between the tracks of protons and mesons in an emulsion. They concluded that many of the charged particles arrested in their plates were lighter than protons, their mean mass being. So he wrote the physical basis of their method was correct, and their work represents the first approach to the scattering method of determining momenta of charged particles by observation of tracks in emulsion. So there is absolutely no doubt that it was really a pioneering and path-breaking work, and it is really very, very unfortunate that, that they could not procure the more sensitive plates, and this research could not be carried out towards a Nobel Prize. Now, Bibha Chowdhury somehow did not, although she had so many papers, she did not get her PhD with these papers, and there is no discussion on why. But she moved to PMS Blackett's lab in Manchester, and this is very, I think she moved in 1945, and this is very remarkable that, she was working in cosmic rays, and she was aware that, where the best research is done. It is never mentioned anywhere whether she got any fellowship for that, or she went self-funded herself to go there. That is not mentioned, but no fellowship is mentioned. For instance, if you read about Anna Mani's story or Rajeshwari Chatterjee, you can see mention of fellowships. That is not, I have not found at least. So she worked on penetrating particles associated with extensive air showers in cosmic rays. And she submitted her thesis in 1949, and this is the title, Extensive Air Shower Associated with Penetrating Particles, and she was awarded a PhD in 1952. So this is, now what is an extensive air shower? So what happens is that when the high energy particle enters the atmosphere, and then it causes a chain reaction and multiple scattering, and that causes a lateral spread of the shower particle, and the particle density decreases with increasing distance. This was first discovered by Bruno Rossi in 1934, and he placed 3 Geiger counters in a single array, which could not be discharged by a single particles traveling in a straight line. Yet coincidences were recorded. So that proved that, the air shower has an extension. So Bibha Chowdhuri worked on that, and this is the thesis work in a nutshell. So this photograph shows that, this CC prime is a cloud chamber, and these 4 are GM counters. And what she measured was the density spectrum of penetrating showers by taking photographs in a cloud chamber surrounded by 4 GM counters. And in the summary of her PhD thesis, she wrote that the penetrating particles are mainly produced in the local absorbers and do not come from air, along with other soft shower particles. So some observers were kept, and the cosmic ray will hit there and produce the secondary particles. So she published 2 papers on her PhD thesis, and one of them was in Nature. She joined TIFR in 1949 as a research fellow. She has not obtained her degree by that time, but she joined as a research fellow in 1949, and she continued her study on large air showers using cloud chamber techniques. So this is from TIFR archives, which says that, during Bibha Chowdhury's absence, someone else will be in charge of the cloud chamber. So which shows that Bibha Chowdhury was in charge of the cloud chamber group in TIFR, and 2 students worked under her guidance there. Though one left within a year due to ill health, the other student worked with her till she left TIFR in January 1954. And this was some description of Bibha Chowdhury's work from TIFR internal report. It is difficult to read, but I have, taken this from Physics News. The IPA newsletter brought out a special issue of on Bibha Chowdhury, and from there I have taken it. And so it is a description of our work on extended air shower, and the paper which was published. And so this was a proceeding in Indian Academy of Science proceeding, and then she published 1 paper on these investigations at TIFR. Bibha Chowdhury left TIFR in January 1954, and she went to Shibpur BE College to join there. And but at the end of 1954, she left for abroad. So in 1954, she joined Professor Prince Ringwet at Ecole Polytechnique. Professor Prince Ringwet's groups observed the first evidence of a heavy meson. Dr. Chowdhury studied properties of K mesons with multiple cloud chambers at the laboratory at Alps, and there was not much, not much was found about this. It is only when I was checking the PRL records, I found a handwritten CV by her in which this part was there, and so this part was not known. Even the book Jewel Unearthed, which was brought out by Rajinder Singh and Suprakash Roy, that book also did not have much information about this period, 1954 to 58, and which we found in PRL records. And so this, so not much details is there, but one can read elsewhere that, these conditions were very harsh. There will be very cold and snowstorm, and but she worked there. So, all this shows her passion for the subject, like at that time going to this Darjeeling and Sandakphu and to do this work, and then again going to these various laboratories to learn the techniques, showed that how much she was her passion and her intention to learn the new techniques and from the best people. So all this, I think, speaks a lot about her courage and conviction and dedication. And a paper was published in Nuevo Cimento on this work. And then in 1957, she joined University of Michigan as a visiting lecturer and was involved in a research project on air showers using the technique of pulse ionization chambers. And it was in Professor V. Hansen's laboratory. And in the last 2 months before leaving to India, she visited Professor Bruno Rossi at MIT. I mentioned that Professor Bruno Rossi was the first to discover the extended air shower. So Dr. Chowdhury visited him and worked on investigation of air showers using plastic scintillators, a technique that she used later when she worked in PRL. And main initiators of these works were John Lindsley and Livio Scarsi. And she was in touch with Professor Lindsley, and Professor Gautam Gangopadhyay of Calcutta University has recently written a book in Bengali. It is not yet published, but it is, he shared the script with me, and it's called Nakhotre Naam Bibha, and in which Professor Gangopadhyay found some communication between Dr. Chowdhury and Professor Lindsley, and by writing to these people, and then that he has included in the book. So this is the handwritten CV that I was mentioning, and I know it is not very readable, but I just thought that I will show you just as a historical document. And what I found in PRL records is that everything that she was giving was by handwritten, and then there will be a typed copy of that. And the typed copy of this is published in the Physics News, January to June 2021, special commemorative Bibha Chowdhury issue. And you can take a look at this, and then you can see, like mention of showers and plastic scintillators and in Mexico. Sorry. Yeah. So with that begins the PRL chapter of Dr. Bibha Chowdhury after 1958. So I thought I will just briefly mention what PRL was doing at that time. This is a picture of the PRL main campus, 1954. And the laboratory grew out of a quest and a dream of Dr. Sarabhai. The quest was to know more about the then mysterious particles of very high energy known as the cosmic radiation. So Sarabhai was very, very interested in cosmic ray research, and the Physical Research Laboratory set up a research station at Gulmarg in Kashmir in 1955 for the measurement of cosmic ray intensities as well as atmospheric ozone and night air glow. The successful working of this station and the important results obtained there led to the establishment of a full-fledged high-altitude research laboratory at Gulmarg in 1963. In addition to Gulmarg, Dr. Sarabhai also had set up outstations of PRL at Kodaikanal and Trivandrum to continue the investigation of cosmic ray time variations. So Dr. Chowdhury worked under 4 directors of PRL, Dr. K.R. Ramanathan, Dr. Vikram Sarabhai, Dr. Menon, and Dr. Lal. And this is a publication list from a resume which she submitted in 62. And she mentioned some 7 papers, but there were, you can see 1, 2, 3, 4 nature papers. But later we found she had also another nature paper, which somehow she has not included here. And this shows her sign. So I thought just, it may not be very much readable, but it's a really valuable thing to show her handwriting and her signature. So Bibha Chowdhury joined PRL in 1959 as a CSIR SRF to work at the Kodaikanal Observatory. She had detailed correspondence with Dr. Sarabhai before this, and in fact they discussed some project at Rajkot, and which Dr. Chowdhury told Sarabhai that may not work. And then when she joined as a CSIR SRF, the project that she submitted was on studying nuclear interactions in ultra high energy region. And she proposed two types of detectors. One is plastic scintillators and one was neon flash tubes. Now, she worked for 2 years and almost completed the part of the air shower survey equipment. And she wrote that, but there were certain parts which had to be brought from England, and those parts were missing, but certain parts were done in PRL. And she was working in Kodaikanal, and the plan was to set up a station there. In 1961, she joined as a CSIR pool officer, and that project was study of cosmic ray showers under Dr. Sarabhai. And Dr. R.P. Kane, he is also the first student of Dr. Sarabhai, and may not be first, but he was student of Dr. Sarabhai, and he wrote in the PRL library, I found one document in which he wrote that with the arrival of Dr. Bibha Chowdhuri, a new chapter was opened with installation of extensive air shower experiments at Kodaikanal. So this is a photo from PRL records. This is Bibha Chowdhuri with Dr. K.R. Ramanathan. And a report sent to CSIR by Dr. Ramanathan in 1963 describes Dr. Chowdhuri as a mature, steady worker, as well as friendly and cooperative. So Bibha Chowdhuri joined a PRL as a fellow in 1966, but before that, in 1962, she started planning an experiment to study high energy muons associated with extensive air showers. So the Kodaikanal project was not anything done about it later, and then it was shifted to KGF. And because I think they wanted to study the muons, so it was better to go underground. And this was in collaboration with TIFR. And for this, she started again on working on scintillator detectors with neon flash tubes to get a visual record of the particles. And neon flash tubes were made in the glass blowing section of PRL. So she worked there. I will come to her work in the next 2 slides, the work that she did in PRL. But she was transferred to Ahmedabad from KGF in 1973. And she retired from PRL in 1976. It was written by her PhD student Yogesh Saxena in an article that she had planned some experiment on radio frequency emissions associated with extensive air shower arrays, which could not materialize due to untimely demise of Dr. Sarabhai. I did not find any correspondence regarding this in the records, but Dr. Saxena mentioned it, so he must be knowing because he was his PhD student. So this was planned to be in Mount Abu. PRL has an observatory in Mount Abu, but somehow this work was not, it did not materialize. So this was the KGF experiment. They studied the cosmic rays and they had these plastic scintillator detectors, and they had lead, so scintillator, and then they had photomultiplier tubes, and this is lead shielding, and then used set of GM counters. And this is one result, which is variation of total number of muons of energy 150 GeV, which they found. And they published 3 papers on this, and 2 of them were in Pramana and 2 in Proceedings of Indian Academy of Sciences. Now, what Dr. Saxena told was that he said that the papers were of very good quality. They could have been published in foreign journals, but at that time, Dr. Chowdhuri wanted to publish the papers in the Indian journals only. So that was what he told. And this, again, in Physics News, he has written a detailed article on this if you are interested. So this is a photo from PRL. This was also I got from Dr. Saxena, and you can see that Dr. Bibha Chowdhuri sitting here among all the PRL scientists, and you can see the the picture that that she was the only woman who is seen in this photo. And so there are many well-known names, at least for PRL people, and maybe for others also. And So this is a photo. And what Dr. Saxena told about his supervisor was that Dr. Saxena actually joined IPR and he has retired from IPR now. And he said that she had an incredible good understanding of the subject and was of great help in analyzing and interpretation of the experimental data. And Dr. Kasturi Rangan, former chairperson of Space Commission, told that her way of teaching helped us very much on the aspects of problem solving, thinking originally, and using your own understanding on the basic principles. So Dr. Saxena states in this article that when he wanted to join Dr. Chowdhury, then everyone said that she is very strict. But Dr. Saxena found that, she was very kind and concerned, and when she was taking very much interest in every aspect of his thesis. And for instance, he had to register in Gujarat University, and Bibha Chowdhury by that time was not registered as a PhD supervisor in Gujarat University. So Dr. Saxena registered under Dr. Sarabhai. So that's why when we find PRL alumni list, we never found Bibha Chowdhury's name, because Dr. Saxena was registered as a student of Dr. Sarabhai. Only later we came to know that he was actually student of Bibha Chowdhury. Like, if you see the web page, then he is formally registered as a student. Another story which he told was that in Gujarat University needed the one foreign language proficiency, and then Bibha Chowdhury volunteered to teach him French. So these are the kind of anecdotes that he has shared. There is also another one that for some reason they had to go underground. There were some problem and in KGF, and then Bibha Chowdhury also wanted to go, but then they told her that, madam, we will manage, but she would be standing there until they come back. And so there were a lot of these kind of things were there. Like, for instance, in the Physics News article, someone has mentioned that when they went to Kolar, then she hired a bungalow, and then she allowed her student to stay there. In the same bungalow, she shared the bungalow with them. So there are a lot of this kind of anecdotes which showed that, what kind and concerned person she was. So Bibha Chowdhury came back to Calcutta after retirement from PRL in 1976. She continued to work with scientists from Calcutta University, SINP, VECC, and IACS. And she worked on understanding nucleus-nucleus interactions and high energies, and she published about 6 papers, last of which was in 1990, before she passed away in 1991. So this is a picture of Bibha Chowdhury from international conference at Pisa in 1955. This was from the book Cosmic Quest by Sukumar Bishwas, and at that time she was in France. So I think she went there from France, and you can sort of see, that how it is like this happens many times, that it something might not have happened, but this picture, if you interpret it, then sometimes you can feel that how sometimes a woman can get little bit sidelined, or in the because it's not if there is a majority group, then that happens for all kind of minorities. So this picture may not be that, but somehow it can be considered as a symbolic thing. Now there are a lot of discussions about Nobel Prize, and I am not sure whether, in their paper, because they were not nominated, they did not mention anything about Pion. And however, what strikes me as very unfortunate and, very surprising is that the Bibha Chowdhury's name remained unknown to the future generation, despite her pioneering works on cosmic rays and being the first woman to do research in particle physics in India. I studied in Rajabazar Science College. I was very closely associated with, I am also Shaha Institute. I was in Shaha Institute also but that is around 2000. And I studied in Calcutta University in 1985, 87, no, 89, 90 during that time. And then I also, I am in PRL, but until very recently, maybe 5-6 years back, I have not heard about her at all. And her house in Calcutta was very close to my house. It was very near to the school where I studied my higher secondary. And with all these connections, I have never heard of Bibha Chowdhury. And I am also doing research in particle physics in, INO, which is related to cosmic rays, but I have never heard of her. So that is really, really, it's terrible. It's very surprising. It's very remarkable that why that happened. Her going abroad in pre-independent India, doing experimental research in a male-dominated field shows exemplary courage and conviction, as I have mentioned. And the question arises that why she remained a hidden figure. Did she face any problem in TIFR and PRL, or the environment was conducive for her? Now, in TIFR, she was not for many years. It was like maybe 4 years, 49 to 54. So yeah, 6 years. And from PRL records, I found that she had a lot of support from Dr. Sarabhai and Dr. Ramanathan. And it was mentioned that she needed certain materials needed to be procured from abroad, which might have slowed down the work, because people ask this question that in PRL, her publication is not very much, she didn't have too many publications. So why that happened? So I don't know, like she started a new experiment. It may not be easy to start a new experiment at that time. And also there were these problems of getting things from, abroad. I really don't know. But I didn't see anything from which I can conclude this. But, and I did not see many people in PRL, who had really interacted with her. I asked Professor Bimla Bhuti, but Professor Bimla Bhuti, because they had a small overlap, but Professor Bhuti said that she was in Chicago and Dr. Bibha Chowdhury will be mostly in Kolar. So somehow she did not have any overlap with her. So then the question arises that was there a gender discrimination overall? And what S.C. Roy and Rajinder Singh wrote in their book was, here gender discrimination means that she was not elected as member of any of the 3 science academies, though her work was high quality. Chowdhury's name does not figure anywhere in the writing on cosmic particle research done at KGF. And in this editorial of Physics News special issue, we wrote that while her male contemporaries, both at TIFR and PRL, went on to make substantial mark at national and international levels, unfortunately, Bibha Chowdhury remained on the periphery in the subsequent years and was forgotten by the scientific community. Throughout her life, she remained unfazed by all the inattention, immersed in the pursuit of science. And, this is not really in India. If you see the history of science, then it is important to note early that this was written by Margaret Rossiter in Women Scientists in America, and Struggles and Strategies. It is important to note early that women's historically subordinate place in science, and thus their invisibility to even experienced historians of science, was not a coincidence and was not due to any lack of merit on their part. It was due to the camouflage intentionally placed over their presence in science. So what did Bibha Chowdhury, did she say anything about this? In Manchester, which was published while she was doing her PhD, and that is really remarkable that, in Manchester, they interviewed one Indian PhD researcher at that time, and she wrote that she said that it is a tragedy that we have so few women physicists today. I can count the women physicists I know in India and England on the fingers of one hand. So she also, she knew it, and she said this. And the question arises that whether the situation has changed. Of course, it has changed a lot from the time of Dr. Bibha Chowdhury. But, since we are involved in studying these, gender fractions, etc., and we have collected some statistics, I can tell you that If you consider women faculty member in physics, then that remains 13%. Although the the PhD students level, we have about 35-40% women PhD students in physics, but when it goes to the faculty level, then it does not translate there, and it becomes really low 13%, which is that the leaky pipeline problem, and the problem still persists, although the situation has vastly improved as compared to Dr. Chowdhury's time. So this is the book, The Jewel Unearthed. I talked about it a lot, wrote by science historians Rajinder Singh and Suprakash C. Roy. It was published in 2018 by German publishers, and that actually made Bibha Chowdhury's name in the forefront, and we came to know about her. Actually, I came to know about her little earlier. This was Professor Srubabati Goswami gave a talk on development of Indian science, and during that time modern science, and then in that she mentioned, and when he gave this talk in PRL, I was sitting in PRL colloquium, and then he mentioned about her, and that was real shock. And an Indian edition of this book was brought out by TIFR and TIFR Alumni Association in 2021. And this was a special issue which was triggered by her biography, A Jewel Unearthed, as I mentioned. And in this, we tried to showcase both the scientific works done by Dr. Bibha and the sheer leap of courage it must have taken almost a century ago to plunge in a male-dominated field in order to pursue science. And this was not our intention to push for individual exceptionalism, but we wanted to look at the past to collect stories of women like Bibha to create an intergenerational network of solidarity. And this aspect is further emphasized in this issue with articles by both senior and junior women particle physicists in the country. So I was one of the co-editors of this issue with Arun Grover and Bandana Nanal, and this is the link, and you can take a look at this issue. So also now what we read in the newspaper was that a chair professorship, Government of India will institute chair professorship in the name of 11 women scientists, and in which Dr. Bibha Chowdhury's name appear. And PRL from last year has instituted Dr. Bibha Chowdhury Memorial Lecture, which was held last year, and this was this year also. We had the lecture already. And this is to pay our homage to this pioneering scientist and to celebrate eminent women researchers in the field of science, technology, and social science. So we organized it during 11th February, between February to March, to International Day of Women and Girl Child in Science and International Women's Day. And this is delivered by some women scientists. So with this, I come to the end of my lecture, and I just wanted to end it with a poem which is in Bengali. And when when we started this Bibha Chowdhury lecture, then I was trying to get some more information about her, and also during the physics news issue. And then there was nothing in the PRL archives apart from what I showed in Professor Kane's lecture and the photo with Dr. Ramanathan. But then when I saw her personal file, then there I saw, I found all these things, her CV, what she was doing during 1954 to 1958. So I was reading about her, and, I was really feeling kind of an invisible connection, and which can be sort of described by this poem that which is written by Rabindranath Tagore, that আজি হতে শতবর্ষ পরে কে তুমি পড়িছ বসে আমার কবিতা খানি কৌতূহল ভরে. So which means, who are you, reader, reading my poems and 100 years since? Of course, it's not 100 years, but I somehow felt an invisible connection that, and I hope I'm able to convey that. I acknowledge the following sources: The Jewel Unearthed by Rajinder Singh and Suprakash Roy, Bibha Chowdhury commemorative special issue, specially articles written by Srubabati Goswami and YC Saxena. The book Nakshatrar Naam Bibha by Gautam Gangopadhyay, Director PRL for permission to use information from PRL records, and several sources in the internet, Wikipedia, for preparing this lecture. Thank you. Thank you.
Thanks a lot. Thanks a lot, Srubabati, for this very wonderful talk and pointing out the important issues. So now it is open. If anybody has any comment or questions, please go ahead. If you have any question, comments. So maybe Srubabati, if let me ask you a question from myself. Okay. So it is not very clear. So this pion measurement issue, which
Yeah.
is also debated recently in many write-up and everything.
Yeah.
So did they understood that in their paper that they are looking at a new particle, which is what Ikawa has prior
It is
theoretically
not
modeled?
mentioned, See, at that time, this what Anderson and Neddermeyer discovered the muon, no, that was called as mesotron, and they always wrote it as mesotron. So I think that because the masses, if you see, then the masses were a little away from pion, and actually they wrote two papers, and in one paper Bhabha suggested them some correction. I exactly don't recall, but and even after that, their masses were like high, so they thought they are seeing proton tracks and mesotrons. So the papers never mentioned. So if you see the title of the papers, always it is called mesotron. Whereas what Powell saw, it was clearly the pion and the muon, so two different particles. But they thought it's proton. My understanding is they thought it's the proton and the mesotron.
That makes sense. Even at that time, it's probably clear.
Yeah, because they didn't have that much sensitivity. So, because they were using half-tone plates, which had on the one side, and then later these people used full-tone plates. And so the, availability of opportunity is also important that, and I don't know how difficult would it have been for Bose Institute to get these plates, but they said they didn't have funding. So I don't know, but it's really a missed opportunity because they were on the right track. That there is no doubt about that.
Whether Bibha Chowdhury she was involved with later particle experiments, most of the cosmic ray type.
Yes.
But whether she was involved with any of the collaboration in theoretical physics or CERN or any of these records are known.
So
what lab or anything.
What Gautam found was that this Professor Leprince, he had discussed with Professor Leprince about, when she was developing these neon flash tubes and plastic scintillators. But other than that, there is no record that she went abroad, because if she was going abroad, then I know it would have been there in PRL record. That was not there. And even Dr. Saxena also did not mention. So I think that she stayed in Kolar and she was developing that experiment, and she was in touch with Professor Leprince. That later Professor Gautam Gangopadhyay has found out by writing to, I think, Fermilab. He found it from the Fermilab archives, and I don't exactly recall why Fermilab she wrote, because it was in maybe Professor Leprince was later in Fermilab. I don't remember that, but that she was in touch. That letter he has found, but she may be with others, but we won't know, because again that record will not be there in the archives, so in the PRL records, but no travel was there. Yeah, actually, when we were studying in Calcutta University, then some of the people tell that some of my classmates that Professor Ashim Ganguly, who was collaborating with Dr. Bibha Chowdhury, has mentioned about her, but maybe I had missed that class, so I did not know. But one or two of my friends told that they knew about her from Professor Ashim Ganguly, who was in Calcutta University at our time.
To be honest, when I was there till 2002 to 2004, we were never mentioned.
We were never mentioned. Even Rohini said that she also did not know, because when she published Leelabati's Daughters, there also we have missed her. So Rohini also said that she never knew, and in so much cosmic ray research history is written, why her work was not written. And at least, developing this, I need to do little more study on this. I have not been able to, but I want to see that, what is the history of, plastic scintillator detector development in India, neon flash tube detector development in India, whereas others have done or not. Those are the things I think that we need to see, because this was not there in the books or whatever. So, but those papers were in Pramana, but Dr. Saxena said that they were very good works also. So
Anyway, if there is any other comments by anybody.
Sudipto, I would have one comment there. What more can be done to pull out such forgotten figures from obscurity? So these university chairs, if I understood well, have been created or are in the process of being created, which is very good. Dr. Srubabati, what else would you suggest that can be done to preserve the memory?
yeah, I think that, the kind of things that you are doing, or, we started this Bibha Chowdhuri Memorial Lecture. So I think that those are the things which can be done, because then, if you organize such a lecture, then for generations, this will continue. Like the Bibha Chowdhuri Memorial Lecture that we instituted in PRL, it will happen in every year. So the new students who are coming, they will also know about her. So that is one thing I think one should do, and we should have more of, science history. And I feel that, people should be more forthcoming to share history and to be open about it. So that is also very, very necessary.
It would be nice if she could find a place in some of our university textbooks on particle physics, on particle physics, for example.
And, that is a really, really very important point you have raised, because one of my colleagues in Hyderabad University, Professor Bindu Bamba, she did a research on, number of women's photos that appear in in physics textbooks. And, the discussion is why physics is so male oriented. And she found that statistics, which is that, very few. So that is really a very, very good suggestion that you have given. And I think, yes, that is very necessary. And yeah, so there are, some initiatives now, because hello. Yeah, there are some initiatives now, and there is a book which was written by Nandita Jairaj and Asima, from Life of Science, which they are also doing popularization of women scientists. They interview women scientists. If you have not seen their webpage, please do take a look, lifeofscience.com. They, single-handedly, these two girls did so much to popularize women scientists in India, and they had a children's book. I think Bibha Chowdhuri appears there, and then many other also practicing women scientists appear there. So these kind of things are, I think, yeah, will go a long way.
Thanks a lot, Srubabati, for this very, very interesting talk.